am a little obsessed with lab-grown gemstones. Not only do I find them to be underrated, they're also one of the coolest applications of science because think about it, gemstones are one of the few things that cross religions and continents. So here are 4 key questions answered so that you can become a little bit more of an expert on the topic.
You're watching S.T.E.M. Today we'll tackle one STEM topic I learned from experts. Just 4 key questions with each answer under 1 minute or less.
The most common definition you find when you Google lab-grown gemstones is that they are gemstones that, rather than being mined from the earth, were created in a laboratory. Now, while accurate, this makes it seem a lot more black and white than it is. I want you to think about the last time you went to a restaurant. Maybe you had a delicious hamburger or a salad with some delicious dressing, and you thought, I'm going to try to recreate this at home because how hard can it be? And then you tried and it tasted nothing like it. Well, that's because in order to recreate the item, you need to know exactly what the ingredients are, how much of those ingredients, and the order in which those ingredients are put together. And that's what makes lab-grown gemstones so difficult. In order for a lab-grown gemstone to be considered the same as its mined equivalent, it needs to be chemically, optically, and physically the same. And that's why certain gemstones like lab-grown diamonds have taken over a century to be able to figure out how to recreate, and they still don't know how to lab-grown certain gemstones like tanzanite, which formed over 500 million years under such specific conditions they can't replicate it, or a gemstone like a pearl, which is formed in a living organism, and all you have is simulant alternatives. The origins of lab-grown gemstones date back to 1883 when Andrew Vernai figured out how to lab-grow corundum, which is the mineral name for ruby and sapphire. It took 20 years for this to become commercially viable, but if you have a pocket watch with sapphire from the early 1900s, there's a chance it was made through this method. Powder is dissolved over a flame that's on a spinning disc, and the gemstone forms over time. Another method that uses melting is called crystal pulling, and this is where a seed is planted into melted materials, and then the seed is slowly pulled out as it continues to grow. The flux method uses a material called flux, and flux actually melts other ingredients, and then as those ingredients cool, the crystal gemstones form. And then the last process is hydrothermal process, and this actually replicates the conditions that happen within the earth, which is a combination of heat and pressure. Now, the method that's selected will depend on the gemstone as well as the cost. When it comes to diamonds, 2 other methods are used to lab create diamonds, one that replicates the conditions that occur in the mantle of the earth, and the other is one that's only been around since the 1980s. When I sold jewelry on TV, I used to discourage customers from comparing lab-grown and mined gemstones because they're not a like comparison. That's like comparing eating out and eating in. You probably do both and you decide one over the other based on a bunch of factors, and they both have their own perks. Gemstones are no different. One of the coolest things about lab-grown gemstones is that you get to experience gemstones that are so rare in nature, there is no option to experience them in a mined form. Take moissanite as an example, which has become a very popular diamond alternative because of its fire and its hardness. Moissanite was originally found in a meteorite, and it's only been found a handful of times on the Earth. So you either buy the lab-grown version or you wait for a meteorite. Another thing that's really cool is that you get to experience or afford gemstones that are very high quality, like emerald, where previously we were lucky if we got to see them in a museum. Another thing that's been debated amongst scientists is the purity. Now, most gemstones that are mined have trace elements based on where they were formed, but because they were formed in a laboratory, lab-grown gemstones don't have those trace elements. So are they more pure? Lab-grown diamonds have taken center stage in the jewelry conversation because of the controversial way in which diamonds are mined, the environmental impacts of mining, and the cost. Diamonds are a very special gemstone. They're the hardest known material, which makes them great for jewelry, also great for other things like cutting steel to give you a sense of their hardness. Also, they're the only gemstone that's made up of essentially one element, which is carbon. Mined diamonds are expensive, not because of their rarity. Sorry to burst your bubble if you didn't know that, but because of the controlled environment, marketing, and their beauty. It's only natural with lab-grown diamonds becoming more affordable that they're starting to gain in popularity. What's cool about lab-grown diamonds is even though they're not 1 to 3 billion years old, like their mined equivalent, it still took over 200 years for scientists to be able to figure out how to lab-grow diamonds, and that wasn't even gemstone quality diamonds. In addition, there's a lot of nuances to the process when you start to get into trying to create things like yellow diamonds or pink diamonds. So while it may seem easy to just add a little bit of an element or create an inclusion, very difficult process. To be a fly on the wall when those scientists finally figured out they had lab created a gemstone, how exciting would that be? I hope they had a really good party to celebrate. I got my lab gemstone on right now. I'll see you next week. Quick little explanation on the difference between simulant and synthetic, which are not the same thing. And a lot of people get them mixed up. A simulant is like, if I dressed like you, I am simulating you. I am trying to be like you, even though we are very different people. Synthetic, though, means it has to be the same thing. So you could only really be a synthetic of someone, kind of, if you cloned them.